Consider two blocks of equal volume but unknown contents. The blocks themselves are of negligible mass, but inside each are different numbers of firmly embedded identical massive objects. The objects are pictured as spheres below. These objects feel pulled down toward Earth's center because they're in Earth's gravitational field. Force vectors show the magnitude and direction of the gravitational force exerted on each object. All the forces in this picture have the same magnitude because the objects are identical in every way, so by symmetry, Earth will pull on them all the same. Systems are often drawn enclosed in dashed rectangles. So each system below contains only one object. But if, on the other hand, we were to combine all the objects in each block into one single system, what would be the strength or magnitude of the gravitational force that's acting on each? Since there's only one object in the box on the right, it feels force F. How large of a force would the block on the left feel? Now, because we get to decide what the definition of our system is, we can group objects together and then add the forces being applied to them into one single force. In this case, it would be a force that is 3 times as long as it would have been in the block on the right. I'll call it 3F. So Earth will pull down 3 times as hard on the left block as it does on the right block. Now, if you've ever done any weightlifting or lifting of any objects really, then you can relate to this situation. The blocks on my previous page could remain motionless if the magnitude of force applied in the upward direction matches the magnitude of gravitational force pulling downward on the blocks. So which of the blocks would be harder to hold up if you were a weightlifter, let's say? Which one would feel heavier to you? I think we can all agree that the block that has more stuff in it is going to be more difficult to hold up. And there'll come a certain point when your body can't even supply enough force to hold up what you want to hold up. What we've just looked at illustrates the concept of mass. Mass is considered to be one of the most fundamental properties of the universe. It describes the amount of material inside an object. Mass is also often referred to as inertia, which would be a measure of an object's resistance to acceleration when an unbalanced force is applied, and we'll see examples of that in videos to come. The kilogram is the System International SI unit of mass. It was originally defined by the amount of material inside 1,000 cubic centimeters of water. Density is a rate of mass to volume. It's the mass per unit of volume. So if the blocks above have the same volume, which one has the greater density? Well, if each of these spheres represents a kilogram, let's say, and each of these blocks represented, let's say, 1 cubic meter, we'll put 1 kilogram as the mass of the block on the right, and let's let the mass of the block on the left be 3 kilograms. Then to calculate the density, we have to divide the mass by the volume. So for this block, it would be 1 kilogram per meter cubed. And for this block, it would be 3 kilograms per meter cubed. So the block on the left would be more dense. Weight, symbolized by the letter W, is another word for the force of gravity that acts on an object. It can also be represented as F with a little subscript g, which means the force of gravity. The weight acting on a system will be proportional to the system's mass.